Welcome to watch the AEC Enterprise Management Solution process steps from plant configuration, resource planning and production controls including integrated accounting. You will be introduced project-level functions and data entry processes that the solution can handle. The solution interactively accesses web and client-server interfaces. Let us assume that a production process plant with rated refining capacity of 100,000 barrels per day. Processes explained in this demo assume that the solution is working on computer machines owned by the company responsible to performing several business functions in operating the plant. It is assumed that highly experienced professionals with knowledge of the production practices administer the system. In the first step we create a project plan in the solution system. Life cycle processes of oil and gas industry involve crude exploration, transportation, storage, refining process and usable oil storage and distribution. Processes explained in this demo are limited to only refinery from crude oil storage to finished products. Petroleum refining begins with the distillation or fractionation of crude oils into separate hydrocarbon groups. Most of these products of distillation are further converted into more usable products by changing their physical and molecular structures through cracking, reforming and other conversion processes. These products are subsequently subjected to various treatment and separation processes such as extraction, hydrotreating and sweetening in order to produce finished products. In the second step, the annual rated refining capacity of 30 million barrels may be analyzed to hourly production and costs to design various plant components. 20 hours per day and 300 days per year are considered into the calculations. Crude oil and refining cost and with average retail prices considered are $113, $19 and $173 respectively. Typical refined products made from a barrel of crude is shown in the image. A typical oil refinery flow diagram showing various unit processes with intermediate product streams occurring between the inlet crude oil feedstock and final end products. The diagram shows only one of hundreds of different oil refinery configurations. The diagram does not include any of the usual refinery utilities such as steam, cooling water, electric power and storage tanks. The flow diagram needs to be reduced to process tasks with quantum of refining for each one of them. Input and output resource forms for every process task shall also be designed and tabulated as shown in the image. Every project should contain a bill of project tasks. Each process task needs quantity of input feedstock. This would output captive stocks for the next processes as feedstocks. All resources are identified for each process task and are created in the system under 4 categories, such as materials, machinery, manpower and services. This should include material resources, either feedstocks or captive stocks. Power required for each machine under each process task needs to be calculated to arrive at budget of project. Thus total plant power requirements can be summed up from these values. Master WBS sets business principles for other similar projects at corporate level. Therefore we defined them at top-level WBS such as fractionation, treatment and conversion processes. We need to configure what are all possible multiple process tasks that a master WBS can contain. Each task may produce captive stock or resources to incorporate into some other tasks or final products. Such definitions are either service or work in progress or finished goods with percentage allocation of expenditure in production. This helps to calculate cost of produced captive stock. To perform every task we need to have its budget in place. In this step we calculate budget for each task. Select a task from tree view. Assign resources like material, machinery, manpower and contract. We can attach assignments from similar tasks within the project or from other projects or from master library. We need to apply latest market prices to each of the resources. For machinery and manpower resources, assigning production capabilities is important to determine durations of project tasks. We may also require to estimate indirect administrative costs and profit margins. A final cost summary can be seen in the report resulting from project budget. The project needs to be scheduled to determine sequence of operations. The determined sequence gives us resource requirements of the project. We use MS Project application to sequence tasks using export and import commands. This becomes a master schedule for the project. Let us plan the project to realize the master schedule. We need to select a planned dates as scheduled in earlier step. Apply the budget so prepared for selected shifts. Perform any changes in the budget while saving as production coefficients. Apply this production to selected or all dates and shifts as second step. In the third step, we need to see if the resources are available to perform shift production. Then we need to assign resources to perform the target production. Resources need to be requisitioned if falling short to perform production. Therefore, let us select a period of production plan and send requisition to the central pool of procurement. Assume that there could be several requisitions coming from different projects at a time. Some resources may be already idling in some other work site. The central procurement management should exercise controls of buying or hiring or diverting resources. For materials we procure through a purchase order, whereas for machinery resources we could optionally purchase them through purchase order for long-term deployment. If project is unviable to absorb investments, we may hire them through a work order. For subcontract resources we need to process only through work orders. For manpower resources we may have labor recruited through HR module. Let us see an example of quick transaction associated with quick PO. The quick trans command assumes that the user self-performs all the processes. Such process steps are raising PO, take delivery of materials, certify receipts, quality checks, billing and posting a journal into accounts. Purchase order, goods receipt note, vendor bill and transaction to accounts are automatically posted to the system. In multi-employee system of management, indents are raised to procurement module. In procurement module, pre-order process is assigned to procurement executives. These executives raise requests for quotations, get offers from prospective vendors and submit to the system. Such offers are compared before a valid purchase order is released. On releasing a PO, the material department takes over control of the receipts. When a material PO is raised, vendors can deliver to designated places. Such record is made as goods delivery notes. The deliveries need to be certified as arrivals followed by quality checks. Then a goods receipt note is triggered for the deliveries before billing. At this point the material is available for consumption to the project plan is seen in stocks. On certification of material receipts, vendor billing is processed periodically as per PO conditions. Billing processes are different for different resource divisions like goods, services and transportation. Our main objective is to execute subtasks so discussed in previous steps. This is after all the procurement process is performed and resources are available. We finally assign resources that include manpower just before execution. We can effect changes to a resource plan depending on the site conditions. We also need to notify the on-site crew members who execute the plan. A master machinery calendar can be viewed displaying total machines with machine ID and number of hours engaged for each day. Machine-wise calendar showing assignments can also be seen with project ID, task and WBS element ID indicating number of hours planned for the day. HRM is fully integrated to operations. Total labor force employed can be seen month and day-wise in planned and executed hours with resource designation configuration. A selected person calendar can also be seen with assignments with project ID and WBS ID with number of hours planned and performed. It is time to have our operations performed as per the budget schedule plan and resources. I have two tabs here, the first one being expenditure tab and the second is for production recording. In expenditure tab we need to key in the machinery and manpower logs, enter materials consumed and subcontract quantities performed. This is performed against a selected WBS shift or element on the current date. We also need to have production recorded of the WBS element for which the expenditure is being incurred. We can enter exact dimensions of the production WBS element in values or in percentage to tell what has been achieved. Assume that the production so performed is acceptable. At this point of time we push the WBS element to a locked state to avoid any further entries. Let us also have a look at the visual project progress with expenditure and financial progress reports such as budgeted cost of work scheduled, budgeted cost of work performed and actual cost of work performed. System-generated transactions at its ultimate automation. Firstly, every update in expenditure tab, the system pulls stock from inventory and pushes to work in process. Similar adjustments are also made to services and machinery resources. Manpower costs, machinery depreciation are pushed similarly. Secondly, when client accepts the work so executed, system fires another adjustment transaction, moving assets from work in process to finished goods. These transactions could be seen in operations and accounts modules. System solution contains engineering and enterprise management modules. AutoCAD tools and custom component modeling modules for quantity estimation. For cost estimation we have an inbuilt budget, using enterprise resources and costs to get real-time project estimate. Sitting on top of all these engineering modules, we have a scheduler for project sequencing. The solution also contains 11 enterprise management modules, such as 1. Accounts management for finance and factory accounting. 2. Bid management for tendering and business development. 3. Corporate management, for corporate-level assets and policy matters. 4. Documentation management, for drafting and controlling contractual and other enterprise documents. 5. Equipment management, for plant and machinery purchase, hiring, maintenance and repairs, project deployment and accountability. 6. Human resources management, from recruitment to terminal benefits including project deployment and accountability. 7. Material management, inventory stocks, conversions, transfers, vendor billing and invoicing issues and project consumption. 8. Network management, for administering user access controls, roles definitions, solution system level configurations. 9. Operations management, being the central core business module, integrating previously stated engineering management modules. Business functions here demand to generate production and revenues. 10. Procurement management, for buying and vendor management catering several department needs. 11. Quality management, for performing day-to-day quality control test on raw materials and finished products including HSE matters. Thank you for watching the video.